Okay, so my name is Casey, and my project was over 5G network architecture. Um, I guess I should start off by explaining just what that means. I'm sure you've heard of the 3G, 4G, and now 5G mobile networks, which our phones are able to run off of. These Gs basically just mean generation. At current, we're using mainly 4G LTE as the fastest mobile network provider. But soon, some estimates say mid 2020s or so, we'll be using the 5G network. Yeah, so 1G was basically just voice for the brick phones you'd see in old movies. They weigh a ton, carry it around in a backpack. Just terrible. And then 2G, that was voice and messaging. Great for, you know, professionals who want to just send quick texts. Nokia was a big provider in hardware. Then we moved to 3G, and that introduced mobile network connectivity. Uh, well, you had PDAs that were able to connect to mobile networks, but 3G was the biggest mainstream provider for mobile networks, and that also came with the biggest proponent was the iPhone. Then we moved to 4G in about around 2008, and that allowed us the speed to not only surf the internet, but to use it to stream video, to use video chat services, and among other things. Now, 5G is where things get a bit tricky. We'll be able to stream Ultra HD video, uh, use the Internet of Things. You should learn about that in another presentation coming up. There's going to be many uses for this 5G network that we will go through in a bit. 1G was stuck at around 2.4 kilobits a second. That's basically dial-up. Very bad. 2G was around 64, still very bad. 3G was reasonable at around 2,000 kilobits a second, or I think that's 2 megabytes a second, which, again, isn't bad, but with 5G, we're looking at more than 1 gigabyte a second. That's faster than most fiber lines nowadays. Of course, whenever you move from 3G to 4G, there were a lot of changes that they had to do with their network architecture, mainly the client side and how they communicate with each other. So when we look at how 4G radios work, we're going to be moving to a much more complex but much more efficient system to handle just the sheer amount of data that's going to be able to be pushed through these 5G networks. Yeah. So the future's looking bright here. 5G networks have have brightened up the future a bit. With over a gigabyte a second and low latency that were promised that 5G will provide, there's going to be massive appeal in several different markets. Just pretty much anything you can think of, such as monitoring water quality, monitoring traffic to adjust your route that you're taking to work in real time. It can see if traffic's going to slow down. It might even incorporate some machine learning to judge based on what that day, the last previous years, has it been, you know, slow, and if you should take a different route. Smart parking, monitoring logistics, smart control, just there are thousands of things. Some interesting uses that I was thinking of and that I saw while researching were drones. Drones really have a limited span of where they can travel right now because they go off of a local network to reduce latency, so the controls aren't lagging, and it makes it drivable. But if you could use a 5G network as your connection straight to your drone with latency as low as 1 millisecond, there's the possibility of you being able to send your drone pretty much anywhere that has a mobile network connection. Of course, that would be 5G, but that opens the door for companies like Amazon to do door-to-door deliveries with drones. That opens the door for better surveillance of businesses and homes. We're also talking about just real-time data for all these markets, and that's just sorry. That opens the door to economic opportunities. So yeah, we have a long road ahead planning this 5G network, because we still haven't gotten through the kinks of a wired network that runs as fast as these 5G networks are going to be able to. So the future will be interesting going forward. Thank you. This was my presentation. I hope you liked it.